Here is the useState hook, a hook we'll become intimately familiar with over this course. It's the one you will reach for the most in our new state-powered functional components, and it's the one most similar to the this.state you already know and love in React. We'll learn how useState stacks up to traditional class state in this lesson and how to replace it effectively with hooks. Okay, so before we dive into actually modernizing our own React application, we are going to look at some examples of hooks to give you a better feel for them in a smaller, easier to understand environment. So the first hook that we are looking at is the useState hook. And below are two interactive examples that I have built in Code Sandbox to show you how the useState hook can be used. There are slight modifications depending on if you need to access previous state to update the current state or not with React. So that is why there are two examples in this sandbox, which I have shown you the actual working sandbox example on the left and the code for the sandbox on the right. And I've also commented out this code here at the bottom, which is for the second example. So all you need to focus on for the first example is this right here. So let's talk a little bit about how it works. So the first example is show message, where if you look at it, it said when show message's state is updated, previous state doesn't matter. So the current show message state is true. And then when show message is true, you see this particular line. And then when we click hide, when it's false, you don't see it. So the show message state is now turned to false. So that is basically what this top example does, and that is what this code over here does. So the top example does not depend on previous state. State of show message is updated from true to false, and the message displayed in the JSX goes from when it's true, you see me, to when it's false, you don't. So let's break down each part of this first example and compare it to its class-based equivalent. We'll look at declaring state, and then reading state, and finally updating the state with useState. Declaring the show message state with useState. So with the useState hook, it returns a pair, the current state value and the function that lets you update it, which is why when you look over at our example code, we have show message and we have set show message returned as an array in JavaScript. So one thing that I would like to point out, similarly to how React custom hooks should all be use something something, it is a best practice to name the function that you are using to update your piece of state as set XYZ. So if we have show message as our piece of state, our Boolean, we want set show message to be the updating function. Or another example that I give up here is if your variable is called isOnline, your matching function to update that variable would be setIsOnline. So it's just a best practice, an easier way to keep track of state variables and their setting functions. So you can call this function from an event handler or from somewhere else. This hook is very similar to what you would see in a classic React class-based component. That would be something like this.state.showMessage and this.setState in a class, except you get them as an array, destructured pair, and this type of useState doesn't merge old and new state together like a classic this.setState does. Be aware that that is how state in React functional components works. If we were looking at a class-based component of this same example, initializing the state would look something like this. We would declare our class component at the top, we would have our constructor with our props, and then we would have this.state and our show message true state. And then the rest of our code would go beneath this. The equivalent code in a functional React component that is using the setState hook looks like this. We import useState from React, or you could use react.useState, but I prefer to destructure them whenever possible. We declare our const app, which is the same as any other functional component in React, hooks or no. And then we have our constant of show message and set show message, the way that it is updated, and then useState and its initialized value, which it starts out as true. Since there is no this in functional components, nothing can be assigned or read from this.state, so instead, the useState hook is directly called inside of this component. Calling useState declares a state variable. Our variable is named showMessage, but it could be named whatever you want. Waffle, location, whatever makes sense for that particular variable. So this is a way to preserve some values between the function calls. useState is a new way to use the exact same capabilities that this .state provides in a class. Normally, variables disappear when the function exits in JavaScript, but state variables are preserved by React. The only argument the useState hook needs is the initial state, true in this case, and unlike with classes, the state doesn't have to be an object. It can be a number, a string, a boolean, whatever you need. But in our example, we only need a boolean to determine if the user should see one message versus another in the DOM. So the initial state is set to true for showMessage variable. If we wanted to store two different values in state, we would call useState twice and declare two different pairs of state. So for example, if we wanted to have one called isOnline, we would declare it in the very same fashion that we declare our first useState. And since this too is named in such a way that it sounds like a Boolean, we'll start it out as a Boolean, but that is how you would have multiple pieces of state in a single class component. A best practice for useState is to declare all the variables at the top of the component right after defining it, like how we declare state values at the top of class-based components today. Just continue to carry that over into your functional components. And now that the state has been set in the component, let's compare how its value is read. So once we have a state, we need to actually read that state and display it in the DOM. So reading showMessage state with a useState hook. If we were doing a class-based component, we would need to update the state of showMessage. So we have already declared our state up here with our class-based component. We render it in the DOM with some JSX, and in addition to whatever JSX needs to be there, we would have this .state.showMessage and a ternary. So when showMessage is true, you see me, and when showMessage is false, you don't. Very straightforward. So instead of calling this .state.showMessage to read the value of showMessage in a class-based component, we can simply call showMessage in a functional component. So in our functional component, and when showMessage is true, you see me. When it's false, you don't. While displaying the value in this example of a class-based component doesn't seem like that much more code, when you have many state variables being displayed in a single component, it can be much harder to decipher what all is going on in this component. Having to not deal with this .state or destructure it at the beginning of a particular component, it saves you a lot of typing. So of course, the next thing we need to do is update, because that's the last but certainly not the least. But updating state no longer involves us calling this .setState to update showMessage. So in our class-based component, we would have a button that would render an onClick, and it would set the state of showMessage to false. In a functional component, we already have set showMessage and showMessage as variables, so the this keyword is unnecessary. And in this example of the button, we just see set showMessage false. Much more compact, much easier to decipher. It's much easier for me to read this inline function, the one in the class-based component. So there is one pretty big difference to keep in mind when it comes to functional state variables versus class-based state variables. Functional state variables can hold objects and arrays just fine, so you can still group related data together. But unlike this .setState in a class component, updating a functional state variable always replaces it instead of merging it with existing variables. Just a little thing to remember, be aware. Okay, so let's move on to our second example, which is an example where previous state does matter. To refresh your memory, this is what our code sandbox looks like, and the example that we're focusing on is this one right here. So when new state does depend on previous state can be passed into the setCounter function below, and it can update this count. So if we click that, every time the count updates correctly, incrementing and decrementing depending on what is already the current count. So that is how this example works. Now let's look at the code. As you saw when I was demonstrating, When you click the Add One or Remove One buttons, the state of the counter number is incremented or decremented by 1 from its previous state value, and that value is reflected into the DOM. So when I go through this example, most of it should seem more familiar after walking through our first example, but I'll be sure to highlight the key differences. Once more, we began by declaring the initial state variable for a variable named counter, which will keep track of a count in the component. So if we were to look at the class-based equivalent, here is what this .state.counter would look like in a class component. We have declared our component, we have instantiated our constructor, and we have this .state and counter with an initialization of 0. And then the rest of the code goes beneath that. And here is how the state named counter is implemented with hooks in a functional component. You can see that I still have show message from the first example above, and now I have a second variable with counter and set counter, which will update counter. And it is starting out with the same variable of 0 as its initial state. So in the initial state declaration, nothing different is happening from our first example. The state counter is declared, its updating function set counter is paired with it, the whole thing is set equal to the useState hook with an initial value of 0. Every time this component renders, its initial count will be set back to 0. Reading the state values is relatively the same as the first example as well. Our class-based app accesses the variable through this .state.counter, similar to how you would do it here in the JSX. But our functional app component accesses this same counter variable in its JSX display with just counter. In my opinion, cleaner. Updating is where the change to the useState hook happens. If the new state is being computed using the previous state, you can pass a function to setState. This function will receive the previous value and return an updated value. If you look at the two buttons from the example, the setCounter function takes in a variable named prevCounter right here, and it adds or subtracts 1 from it. PrevCounter isn't explicitly defined anywhere in our code, but you can imagine it being very similar to prevState or prevProps in class-based components. It works very much the same way. So the class-based component updating state is more readable when the functions handling the updates to the this.state.counter are attached to the button's click handlers. So if we look at this class component, I named these functions remove one and add one for this example, but we have this.setState, we have the value, and then we have prevState.value -1 or prevState.value +1. And then we attach those two functions to our click handlers in here. We don't attach them inline. But in the functional component, I can make the update to counter value an inline function, and it's still fairly straightforward and easy to read. So if we look at our example either here or in our code, right in line in our button, we have our onClick declared, we have setCounter, which takes in prevCounter, and then it is just prevCounter -1 or prevCounter +1. No additional function needed. So when you look at this functional example with hooks, you start to really see the benefits that hooks can bring to your components. The syntax is cleaner, there's a little bit less code to write, and it's easier to understand, at least in my opinion. So I do want to point out that referencing previous state to update current state is a lesser known capability that useState has. I wanted to be sure to mention it clearly so that you're aware of it. If you want to learn more about it, I've got a link to the official React docs, and they are a good place to dive deeper. So if you want to merge old state with new state in functional components, if you want to replicate the behavior of setState, you can do so by combining the function updater form with the object spread syntax or object.assign. Either one of those works. So if you wanted to use the spread operator, which is usually my preferred method, you would take setState, previous state, and then you would spread in all the values of previous state and spread in all of the updated values, which would override any values within previous state that they needed to while not touching the rest. Or if you prefer to use object.assign, you can do so where you declare your new object and then you pass in your previous state and your updated values, and both of them are added to this object. So it's not too bad. It's a workaround. You probably won't need to do it as much as you might think once you start thinking and working with React hooks. So once you see how much easier state handling can be, once state is separated out into multiple variables, and the fact that state is not as seamlessly merged together as it was before will start to matter a whole lot less. So I hope now you feel like you have a pretty fair understanding of the useState hook. We'll see lots of it in the rest of this course, and so you'll have ample time to get comfortable. But for our next lesson, we will take a look at the next most prominent hook introduced with the release of React hooks, useEffect.